rotate the volume of the solid form if we rotated this line around the x-axis. Yeah. So it'd be, yeah, it's make some sort of a cone shape thing like that.
Oh, can you use a code formula?
Wait, what?
Why?
If you rotate that around,
If you rotate that line around the x-axis, what shape would it form?
Like if you turn it into 3D, you like
Yep.
rotate it 360 degrees.
It's like this line is rotated around.
that way. Oh, I was
Yeah.
thinking like this way.
It is, yeah, but
Okay,
yeah. You can do it this way. We'll look at the y-axis in a minute, but if that spins around there.
That makes actually more sense.
Well, wait, yeah, I'm just doing it because it makes the shape nicer than this. Might understand it better. But you can do it both ways, but it makes the same shape. Okay, it makes this cone shape. Now, if you just take that and imagine you're looking at this point and the x-axis, and we've turned our vision to just looking down from this way, this point, which is the x-axis, and this point up here is up here, and we're just looking down from here. There's a circle there, right? Yeah?
Yeah.
Do we see that if we're looking from in here? Okay. Now, the key to this is that there are loads of these circles all the way down of different lengths, yeah? Different radius. What is the radius of the circle? No, it's not 3, no.
6.
Yeah. How'd you get 6?
I put the 3 in the equation.
Yeah, so it's directly related to the equation, yeah, the function. Now, another word for y we often use instead of y, we use fx, yeah? So fx to x. So for the radius of the circle, it is when you sub in to fx. But it's always the height y, isn't it? It's always the height y. This is always the radius of the circle, the height y, the y value here. Okay, so to get one of those areas of circles, it would be the area of the circle formula, pi times the radius squared, which is pi times f of x squared. And if I want to add them all together, going all the way back, I need some sort of sum. And the sum we use is the same as the Riemann sum. So the sum of all those added together will give the volume of that. Does that make sense? All those circles, yeah? So no matter what shape it is, the height of the function will match the height of the circle, and therefore if you add them all together, all those slices together, we get the volume of the solid. Okay, so that's it. It's quite straightforward formula once that becomes clear. It's just the area of a circle applied a bunch of times. We're going to move forward a little bit. I'm going to think about what happens if we want to do it with the y-axis and two functions.
So it's always just going to be it's always going to be just pi multiplied by.
Yeah, because the function is the y value is always the radius of the function. You can put y in here if that makes difference. Y squared.
Yeah, but can it be more than that? Theoretically, because if it goes.
Oh well, if you're looking for a volume of a solid, you wouldn't go around more than 2 pi. If you're looking for the volume of half of the solid, you would just half this answer. A quarter of the solid, you would just quarter this answer. Yeah. You would never. There wouldn't be a reason to go further than 2 pi really.
So if we're looking for half of it, it's just divided by 2.
Yes.
Or
Yes. Same as if you got a volume of a sphere and you want to find a hemisphere, you just divide that answer by 2. All right, let's look at this next one. So we have y is ln x, and between 1 and e, okay, that's really looking a bit weird, is revolved 2 pi around the y-axis. Okay. What does ln x look like again? Neon.
I think that's wrong.
This way,
That way. Looks like that.
this way?
Yeah.
Neon.
Yeah.
Okay, well, for a sketch, let's get more specific numbers, maybe. When x is 0, what's y?
X is 0, y is 1.
One.
Oh, no, no.
It's not
It's a cat. Negative.
Y is equal to ln 0. Surely that's okay, no?
No.
Why not?
E to the power of 3 can't be 0.
Okay, so it's an asymptote here.
Yeah.
Okay, so that helps.
It's like a.
When x is 1, when x is 1, y
Is 0.
y is 0. Ah. So here's a point. We know it's an asymptote up to there, and you're saying it does this. No. Ah, that was what you were saying? Okay, just making sure. So this is the kind of thing that maybe in an exam, if you're not sure of the graph, you can have a little think about it, sub in some values. All right. So as that is rotated around the y-axis, okay, so it's spinning this way this time. Okay, we form some sort of solid that looks
It's a
like
big circle.
like
With what? Oh, yeah.
some sort of
Yeah,
like
yeah, yeah.
shape like that. Yeah. Okay, but we specifically between 1 and e. Oh, between here and e. E is somewhere up here. What value is e again around?
2.1.
Yeah.
2.1.
1.14.
2.86.
Why would I know that?
2.86. 2.7.
2.71-ish. Okay.
8.
Okay. Right. So between here and here, but they want the volume rotated around the y-axis. Now we did, with respect to the y-axis, last week. Was it last week? Yeah, it was. Yeah.
No recollection.
Yeah. If you want to get the area with respect to the y-axis, how do we do that?
Reverse it.
All right. So that's you're thinking, right? I need the function, and I'm reversing it, and I need here and here, don't I?
Yeah.
And I'm going to reverse it, use the y-axis as my basis, dy.
Find the values for y first.
Okay, so my bounds will not be 1 and e, will they?
It's going to be 0 and 1.
Are we happy with 0 and 1 here?
No.
I don't know.
Okay,
I'm
yeah.
confused.
Yeah.
You sum in what?
Well, what we could do is just go, right, what's the y value when x is 1? And we did it already. It was 0. And what's the y value when x is e? So put e in here. And ln e is 1.
Okay.
Okay, so that's how I got these two new bounds. So we've got two new bounds, 0 and 1, because I'm rotating it around the y-axis now. But my function is still y is equal to ln x. So in order to use the y-axis, I got to use dy. And now I have 0 and 1, which are new bounds, but I need the new function with respect to y. How do we do this again?
You turn it in terms of x.
Okay, so what?
Inverse.
What? Yeah. Okay. How do I do that?
So you do e to the power on both sides.
Oh, okay. So e to the power on both sides.
E to the power y is equal to x.
E to the power of y is equal to x. Are we happy with that? You can put in the intermediary stage. I think we did this yesterday. Log e x or something like that.
Yeah.
Rewrite that so you can rewrite it as a power. Okay. Is that it? E to the y? That's the function in terms of y?
Now you gotta do pi bracket square.
Yes. So it's no longer just the area. We're looking for this rotated. So therefore, this is, if you looked at it from the other side, this is a circle, and its radius is the function in terms of y now. So this would be squared, and we'd have a pi, just as we did here. The function is now e to the y. And now I can go on with my journey. So ey squared.
So 2y dy squared.
What?
Oh no.
Integration.
differentiate.
So you can rewrite this as e2y if you want.
Wait, can we not leave it up there? And just add, make it.
Oh, I forget. Maybe not.
You
No,
can't.
you can't.
You can't?
Why not?
No.
Because you're multiplying the.
What's x to the 5
Oh, we
squared?
talked about this before.
X10.
X to the 10. That okay? Multiplied 2 times 5. We can't write e to the 2y, you're saying?
Yeah. Oh, no, we can't.
Yeah, we can. Okay.
Circle.
We can't. Again, no, we can't. Which one is it?
We cannot.
So we can do this. We can multiply these powers,
Yeah.
but we're not allowed to multiply these powers.
not?
But 2 times 5 is still 10. What?
Yeah.
Sir, can I
Yes, we can.
Yes, we can. Okay, we got there. We can. Aiden finally agrees. We can do that. Same rules. Same rules. Indices rules. Don't pick and choose. They always work. All right. Yeah. Yeah. All right. What's this integrated now?
I didn't know.
E2 y by 2.
2y
Over 2.
divided by 2. Yeah.
Yeah.
Okay, we need to remember that one. It's the opposite to the derivation.
Yeah,
Right.
right.
And well, if you derive it, you get a 2 in front. Don't you multiply by 2? So think the opposite with integration. You have to divide by 2 to get rid of that. Do you remember that? Or you can think we did this e to the ax plus b style, if you want to think about that either. Pen is rubbish. Just so you divide by the a. Maybe review that. Pi and then 1 and 0.
So we all need to do.
Woo! Be careful, e to the power 0. Ooh. So this is, are we happy with e squared when 1 is put in over 2?
Yes.
Minus e to the power of 0, which of course is 1 over 2. And that's,
E to the.
you can, that's about as simple as we can make it.
Like that.
Yeah. Yeah.
Yeah.
Okay, and if you want to see a picture what that looks like when it's revolved as a 3D picture, it looks like that. That's pretty cool. Minorly cool, maybe.
That's pretty cool.
No, the coolest one is like the graph of like
Well, this is we're getting cooler here.
yeah.
This next one's cooler. Well, so this next one has 2 functions. You got to